In the video Electromagnetic Waves Part 2, we have studied how Maxwell predicted the existence of the electromagnetic waves, that is, the waves in vacuum associated with time varying electric field and magnetic field, each sustaining the other. Now let's see how the electromagnetic waves can be produced. If we take a stationary charge, it is a source of electric field alone, that also a static electric field which does not vary with time, and no magnetic field is associated with a stationary charge. Stationary charge cannot be a source of EM wave. If a charge is in uniform motion, it gives rise to a steady magnetic field. Once again, a charge in uniform motion cannot produce EM waves. However, if we have an accelerated charge, it produces both electric field and magnetic field which change with time. Hence, accelerated charge is a source of electromagnetic waves. A charge which oscillates harmonically produces electric field as well as magnetic field, both of which vary with time, and hence an oscillating charge can emit electromagnetic waves of frequency with which the charge is oscillating. Other possibilities are an electron in an excited atom. As it jumps from higher to the lower energy state, it emits electromagnetic wave. Similarly, an electron passing close to a nucleus emits electromagnetic waves because it is retarded by the positively charged nucleus. Hertz conducted an experiment. He used this experimental setup where we have two metal plates measuring 40 centimeter into 40 centimeter with their centers separated by 60 centimeter. The metals, they have two rods, metal rods. The plates have two metal rods with small spheres S and S dash separated by a gap of about 2 centimeter, 2 to 3 centimeter. The rods, they are connected to secondary of an induction coil. Induction coil gives high voltage across S1, S2 for a very short duration. And as and when we get that high voltage, a spark jumps between S and S dash. It produces, when the sparking means time varying electric and magnetic field are due to accelerated charge. Hence, we get electromagnetic waves which propagate. For detection of the wave, Hertz used a metal ring with two small spheres, small polished metal spheres S1 dash, S2 dash, with gap almost same as that here. When the gaps are parallel to each other, we get sparks jumping between S1 dash and S2 dash, indicating that there is sufficiently strong electric field which is crossing the gap, resulting in the confirmation that electromagnetic waves are being produced, resulting in transfer of energy from the production part to the detector. The frequency of the EM waves emitted is given by nu is equal to 1 over 2 pi root LC. However, such oscillators cannot produce very high frequency electromagnetic waves like light waves. The orderly arrangement of various electromagnetic waves in increasing or decreasing order of the wavelength or frequency is called electromagnetic spectrum. These are the various parts of the electromagnetic spectrum, with wavelength increasing as we go from top to bottom and the frequency decreasing as we go from top to bottom. The shortest wavelength or the highest frequency part is gamma rays, with the wavelength ranging from 10 to the power minus 4 angstrom to 1 angstrom. The source of the gamma rays is radioactive nuclei. The corresponding frequency range is written in this column. The gamma rays are used in radiotherapy, that is treatment of malignant tissues. They are used to initiate nuclear reactions and a study of nuclear and atomic structure. X-rays with wavelength ranging from 1 angstrom to 100 angstrom, they are produced when fast moving electrons are suddenly stopped in the high atomic number metal targets like tungsten. They are used in medical diagnostics, study of crystal structure, luggage scanning in airports, detection of faults in metals. That is, maybe we are using a finished metal product, there may be a crack on an air trap which can be detected with the help of X-rays. Next is UV rays with wavelength ranging from 100 to 3500 angstrom. They are produced by high voltage discharge tubes. For example, mercury lamp also produces ultraviolet rays, used for food preservation, study of forged documents. They can also be used to detect fake currency notes, study of molecular structure, and are also used in water purifiers. The visible light has a wavelength range of 4000 to 7800 angstrom, with this as the corresponding frequency range. They are emitted when excited atoms are de-excited and go to the lower energy state. Black bodies at suitable high temperature also emit visible light, and the metals, for example tungsten filament heated to incandescence, that also emits visible light. They cause chemical reaction. For example, photosynthesis is possible in presence of light. Produce sensation of vision, that is help us to see the world around us, also used in photography. Infrared rays, they have the wavelength range 10 to the power minus 3 millimeter to about 5 millimeter. They are produced by hot bodies and molecules which are excited. Used in cooking, heating. They also relax muscular pain. They are used in haze photography in absence of visible light, and they are also used in cricket reviews these days. Next is microwaves with wavelength ranging from 0.1 centimeter to about 30 centimeter, produced by gun diode or vacuum tubes like klystron. They are also used in cooking in microwave ovens, radars for detection and ranging of the aircrafts, and used in satellite communication, particularly geostationary satellites. The still larger wavelength waves, electromagnetic waves, are radio waves with wavelength ranging from 1 to 600 meter. They are produced by LC oscillators and are used in radio astronomy. For example, the radio waves, they have helped in detection of heavenly bodies known as quasars or quasi-stellar radio sources. They are used in radio communication and TV communication.